Hello and welcome to the part 2 of lecture number 5. We will continue the discussion on lists, numbers and strings in Python. First we will look at some more operations possible on lists. We will look at concatenation and repetition. So we will soon see what these terms mean, what is meant by concatenation and what is meant by repetition. So both these operations will result in a new list. Okay, so we look at some of the operations possible on lists in Python. First, we look at the length or the len function or len operation, which returns the length of the list. That means the number of items in the list. So here in this example, there are 3 items, and when you call the len function on the list, it will result 3. So this is getting the length of the list. And then number 2 is concatenation. Concatenation is performed using the addition operator or the plus sign. So for example, when you have two separate lists, you can use the plus operator to put those two lists together. So we refer to this as concatenating two lists, and it is done using the addition operator. And the third one is repetition. Repetition is done using the multiplication operator. For example, here you have a list containing just one item. You can perform the multiplication operation on this to repeat that element for 4 times. So this is the example for repetition operation available for lists. And then the fourth one is checking the membership, whether a certain item is included in the list. So in keyword is used in this case. 3 in this list. If it is true, if it is included in the list, this will return true, otherwise false. So this is checking the membership, whether or not a specific item is included in a list. So that checking is done using the in keyword. The last one in this list is the iteration. We have actually seen this multiple times before. We can iterate through the elements of a list using a for loop. That's the easiest way. So for x, so this is the iteration variable. In, you have to use the in keyword in this list, and then you can print the items of that list. So this is iteration. So these are some of the commonly used operations available for lists in Python. Here we look back at indexing and slicing to see some further examples. So for example, you can access any element using the index accordingly, the position index. So when you say L, so this is the example lists having 3 different items, 3 string items, and when you call 2 L within square brackets 2, it will point to the index 2 item, this one. So the result will be spam with the uppercase. So the offset start at 0. Yeah, starting at 0, you can go forward in the indexes to access the next elements. And notice that you can also use negative numbers to access items in the list. In that case, what happens? Now in that case, we are counting from the last item or the right. So -1 is the last item, -2 is the one behind it, and -3 is the one behind it. So on, you can use negative numbers to address or access the items in a list. So in that case, it is starting from the last item. We generally start from the first item, right? So the first item is index 0 item, and the last item is index -1 item. So that is also possible. So this will output, or the result will be spam with a capital S, because this is the -2 indexed item. And then slicing, we have we are somewhat familiar with that. So when we say something like this, it is to start from index 1 and go until the end of the list, until the last index of the list. So here in this example, index 1 is this and the last item is this. So it will slice accordingly. So slicing fetches sections. In this case, the section is these two. Exclude the index 0 item. The other two items will be fetched. So this is how indexing and slicing is performed on a list in Python. Here is an exercise for you to try. So you are expected to complete the following code to print all the even numbers in the list. So you are given a list called num list, and it has how many items? 8 items. It has both even and odd numbers. So you are expected to write a program to print all the even numbers in the list. So the expected output would be a list containing the even numbers 2, 4, 6, 8. Notice that there are repeating numbers as well. So you don't want to include the repeating numbers. So think about it. Think of this, pause for a while and think how this can be achieved. So before you actually look at the solution which will be provided in this lesson, I recommend you to try this out by yourself. Think about it, how to implement this. It's not very complicated. From the things that you have learned so far, you can implement this. So take some time to code this, to write this code to get the expected output. Now here's the explanation or the solution for the previous exercise. So we have a num list having 8 items, having both even and odd numbers, and then we have to define an empty list, our own list, for to store the even numbers. So we call that even list, and then we have to iterate through all the items in this list. Okay, so how do we do that? We use a for loop. For I is the iteration variable, I in num list. And inside the for loop, we do two special condition checks. First one is whether the I modulus 2 is equal to 0. So this is to determine whether the number is even or odd. If the modulus 2 value is equal to 0, that means the value is even. So we need the even numbers. So if this condition becomes true, that means it is a value that we want to store in this list. But that is not the only condition, because as we said before, there are repeating items. So as you can see, 2 is repeating, 4 is repeating, and so on. So we don't want to put those repeating or duplicate items into this list. So that's why we have the second check. So what is the second check? Whether I is the value coming from the iteration, I is not in even list, because whenever we find an even number, we try to put that into the even list. But if the value is already included in the even list, we don't want to put that. So that's why we check whether I is not in even list. If both these conditions become true, the coming value in the iteration will be appended to the even list. So think about it. In the first iteration, 2 will be coming. 2 modulo 2 will be 0. That condition is fulfilled. 2 is it in the even list? It will not be included in the even list because nothing is right now in the even list. So both these conditions will be satisfied and 2 will be appended to the list. And then comes 4. The same happens. 4 modulo 2 is 0. This is fulfilled, and 4 is not in the even list. 4 will be added. But whenever it comes to, for example, once again another 4 is coming, that when this 4 is coming, this condition will be satisfied, but this will not be satisfied because a 4 value is already included in the even list. So that's how so this will iterate until the end of this num list and find out all the unique even values. So that's how this program is implemented to find out the even numbers in this given list. Here's a fun piece, since we have discussed about many things about lists in Python. So this is about the developer or the programmer and the tester. So the developer is always thinking how to make it, how can I make it, and the tester on the other hand is thinking how to break it. So even though the tester is thinking of breaking it, it's not in a bad intention, because you need to test. So whatever that is produced by the developer has to be properly tested by someone else. So this is done by the tester. So both these people have to do a very good job in order to produce a good result. That means a computer program. So both these roles are very important in the software development procedures. Now we start looking at numbers in Python. So far in the examples, actually we have seen few operations and many examples about using numbers in Python, but we will formally start looking at numbers and what are the specific operations available for numbers in Python. So number is a data type that stores numeric values. So that is the basic definition of numbers in Python. And the number data type is immutable, right? So similar to string data type, it is immutable. So you can't manipulate, or you can't update the values inside a number. So changing the value of a numeric data type results in a newly allocated object, and number objects are created when you assign a value to them. For example, you can have different variables. var1 is equal to 1 is assigned to var1, and 10 is assigned to var2. So we are continuing the discussion about numbers. So we can actually delete the reference to a number object by using the del statement. We have seen the del statement previously to delete items in a list. This can also be used to delete the references. Okay, so how is the syntax? How do we use the del statement or del statement? We can have either one variable or more variables in front of the del keyword. So that means we can delete a single object or multiple objects at one time. So for example, del var will delete the reference var, and you can have multiple such deletions in a single line as well. So here are the number types available in Python. So we already know what integer means. It's formally known as signed integers because we can represent both positive and negative numbers using integer. So in the case of integer, they are whole numbers, so there are no decimal places. Then we move to the floating point type or float. So these are real values which can include decimal places. Okay, so when you define a floating point number, it always comes with a decimal place. And then thirdly, we have complex numbers. So Python supports representing complex numbers as well. So there's a real part as well as a imaginary part in a complex number. Python supports lots of scientific computation, so complex number representation is quite important in that perspective. Continuing with details about these three different number types, integers, starting with integers or signed integers, they are called just integers or ints. They can be positive or negative, whole numbers with no decimal point. So there's no limit in the integer type, but of course it will be limited by the available memory. And floating point, as we have already established, they are having decimal points, so they are real numbers which have the fractional parts. So it sometimes can be noted in the scientific format, scientific notation, whereas E, there will be a E part representing the power of 10. So if you see something like 2.5 E2 as the output, that means 2.5 times 10 to the power 2, which is equal to 250. So this kind of output, it is possible sometimes that you will see that kind of output. So if you see that, that is a floating point number. So we have to get the 10 to the power 2, 10 to the power calculation to get the number, calculate the number. And then third one is complex numbers. So there's a format to that. So a plus bj, a and b are floats, and j is the imaginary part, or capital J or simple j represents the square root of -1. So which makes a imaginary number. So a is the real part of the number and b is the imaginary part. So it's equivalent to what we do in mathematics. So in mathematics perspective, we represent a complex number in that way, in which includes the real part as well as the imaginary part. Okay, now we look at type conversions, because these number types, they allow conversions between different formats. So we will look at how it is done. So starting from int. So for example, if you have int and within parenthesis you pass another value, this will convert whatever that inside value to an integer. For example, if you pass a floating point number with decimal places, after this procedure it will be a integer. That means it converts into a plain integer. Same happens with float. If you pass a number into this float function, it will convert to a floating point number. If you pass the integer 2 into this, the output will be 2.0. Input was just 2, but output will be 2.0. So in that case, the type was converted to float. Can be converted to integer as well as can be converted to float. So the complex conversion is also possible. Using the complex function, you can convert x to a complex number with real part x and imaginary part 0. But if you want to really represent complex numbers, you need to have a imaginary part as well. But type conversions are possible. And you can actually have the complex part as well using two parameters. This is to convert x and y to a complex number with real part x and imaginary part y. X and y should be numeric expressions. So this is how you do type conversions in Python, especially regarding the number types in Python. Here's an interesting statistic. However, this is from some time back in 2014. So the graph tells you the number of top 39 US computer science departments that use each language to teach introductory courses. So even back in 2014, Python was the leading contender for that. After Python, we have Java, MATLAB, C++, C, and so on. So Python, I think, still should be leading, even though this statistic is from some years back. Python is quite popular these days, I mean nowadays as well. So it should be the leading contender for introductory courses. So for you also, it has been the leading contender to be used as the medium of instruction, for the vehicle to teach programming fundamentals. That Python language has been selected. So now we move on to formally introduce strings. So as we have seen already, strings are amongst the most popular variable types in Python, because we have already been using it a lot. Even though we were not formally introduced to strings, we have been using strings quite a few times. So we can create strings or define strings by enclosing characters in either single quotes or double quotes. So those two possibilities are there. So single quotes same as double quotes. There's no real difference between these two. This is also a string and this is also a string, and these are equivalent. So how do you make a string or create a string variable? That is done by assigning a value to a variable. For example, var1 is equal to, within single quotes, hello world, and var2 can be within double quotes, Python programming. Both these are strings. var1 and var2, both these are strings that have been assigned values. So we move along with string operations. So concatenation of strings is possible, as well as repetition of strings is also possible. So similar to what we did in lists, we can use the plus or the addition operator and the multiplication operator respectively to do concatenation and repetition. So this can be another way to create new strings. For example, concatenation. So we have a variable name called word, and then this is one string, this is another string, and we concatenate those two strings using the plus operator, addition operator. So the output would be help A, right? And repetition is also possible using the multiplication operator, the asterisk sign. So you can multiply the word by 5, that means repeat 5 times. Okay, so now the word is help A, and if you multiply that by 5, it will be repeated for 5 times. So these two strings are also added at the beginning as well as the end. So there's another way, two string literals next to each other are automatically concatenated as well. For example, if you put something like this, word is equal to help and A without any operator, putting them together will also concatenate. However, this will only for two literals, not with arbitrary string expressions. So these are different ways to manipulate strings, different string operations available. So we move forward with further information about strings. So this time about accessing elements and slicing. So this is actually similar to what we did in lists. We could access elements using the index. Similar to a list, string is also zero indexed, and slicing can be done in a similar way as well. So when you do the slicing, it will return a new string. It will not change the original string because strings are immutable. So another important thing to note is that Python does not support a character type. So some other programming languages like Java may support character type, but Python does not. It is actually in Python's perspective, a character is just another string. It is treated as a string of length 1. Can also be considered as a substring. Okay, so even when you have just one character, you enclose that within single quotes or double quotes, and that's fine. Okay, so how do we access the individual elements? Using the index, right? So use the correct index and you will get the corresponding character. So for example, here we have a concatenation operation, help plus A, and when that is done, it will have how many characters? 5 characters. So when you say word 4, we are asking for the last character, right? So because index is starting from 0, 0, 1, 2, 3, 4, that means 5 elements. So when you say word 4, it is accessing the last element, which is A, right? So that is the expected output. And substrings can be specified with the slice notation. This is once again also similar to what we did with lists. We can define the starting index, which will be included, and this is the stopping index, which will not be included. So when you say word 0 2, that means to start from the beginning but stop at 2. Do not include index 2. That means H and E only, because index 0 and index 1, H and E. So this will be the expected output. And we can take anything in between 2 to 4, include 2, include 3, but do not include index 4. That means we will get LP as the output. So that's how slicing is performed on strings. So we can access elements using the index, and we can do the slicing using once again the index range. So that's how we perform the slicing and access elements in strings in Python. Move forward with the information and examples on slicing and accessing elements inside strings. So we have the same example. The word is help A. So we can also use negative indices. So when you say -1, it will be referring to the last index, the character at the last index. So it will return capital A in this case. And when you go -2, the last but one character, that means the previous character. So that will be P, simple P. And you can do slicing using negative indices as well. So when you say -2 : nothing, that means get the last two characters. So last two characters means P and A, PA. So when you say :-2, get everything except the last two. So that means exclude PA, get everything else. That means HEL. So these are different ways to access items and do slicing in strings in Python. Here's another simple example. We have two string variables, var1 and var2. var1 having hello world and var2 having Python programming. There's a slight difference between var1 and var2 because var1 is having single quotes and var2 is having double quotes. Right, so there's access of elements in the first line, in the first print line. So from var1 access the index 0 item. So what is the index 0 item? Here in var1 it will be H. So this is the expected output. And then in the second print statement we are accessing var2, but this is a slicing operation. Start from index 1 and end at index 5, but do not include index 5. So start at index 1, this is index 1, y 1, 2, 3, 4, but don't include index 5. So that means you will get YTHO out of this var2 string variable. So that example shows you how to access and slice strings and get output. Now if you look back and recall your memory about lists, we were able to change items inside lists. We were able to update list items, right? But asking the question, can we do the same for strings? Can we update the items inside strings? The answer is actually no, they cannot be updated or they cannot be changed because Python strings are immutable. On the other hand, Python lists are mutable. The items inside the Python list, inside a Python list, can be changed, but it is not the case with strings. So we can demonstrate this using an example. So here we are assigning to an index position in a string will result in an error. So what does that mean? For example, let's take once again the same word help A, which concatenates help and A. and we will first try to we will try to reference to the index 0 element of the string, and try to assign or try to update the value in at index 0, basically the index 0 item of the string. If you try this, you will notice that there will be an error. So the error is given. So there will be a type error complaining str object does not support item assignment. Why? What is the reason? The reason is strings are immutable. They are not allowing you to change the items. So item assignment is not allowed by strings. So we cannot update the items or elements inside a string. So we are emphasizing on the fact that strings in Python are immutable, unlike lists. So we can actually create new strings using parts of already existing strings with the use of combinations. We call that we can have combined content. For example, we already have the word string, and we can slice different parts of that word and add to some other new strings as well. That means concatenate. By concatenating several parts, you can produce new strings. But never we can never change the existing strings, because we have seen that very clearly, because the strings are immutable. So in different ways to concatenate we can do. So this is accessing the element 4 in the word string, and then concatenating with this new string splat, and that will give you splat A. So this will be a new string. So here is another example of an attempt to create a new string. So in this example we have str1 pqr, and we define another variable called str2 and assign the value of str1 to str2. So essentially now str1 and str2 are referring to the same string. So even if you try to print str2, it will be printing pqr. Same goes with str1. However, if you try to do this operation, do an item assignment, it will fail, because it will complain that it's a type error. Str object or string object does not support item assignment. So we have seen this error previously as well, because it does not support item assignment. Let's have a brief look at the id function. So what id function gives us, it returns the identity of an object. So we are working with objects all the time. So we have string objects, we have integer objects, float, or any other objects. Any object has to have a unique identifier. So when we call the id function on an object, it returns the identity of an object. So this is naturally a number. So the identifier is a number, identity of the object. So this is an integer or a long integer, guaranteed to be unique and constant during its lifetime. As long as the object is live, that ID will be there. ID will be available. However, two objects may have the same ID, because if they are referencing to the same object, because it is the address of an object in the memory. So here we have an example. So for example, we have str2, which is pqr, and we also have the variable a. We equal that to str2. A will be also pqr. Now both a and str2 are referencing to this string object, which is pqr. So now if you say id a or id str2, both occasions, or the both operations, in both situations, id function will give the same output, because a and str2 are referring to the same object in the memory. But str1 is something else, because str1 was reassigned to another object. It is referring to this xyz object, and it has a different identifier. Another important thing to introduce with regard to strings in Python is the escape characters. So escape characters are to be used alongside strings, especially when you need to include some unauthorized characters within a string. Okay, let us take a simple example, because we know that a string has to be enclosed within either single quotes or double quotes in Python. What if we needed to include a single quote or a double quote mark within a string? That is not allowed in normal circumstances. In normal circumstances, we can't do that, because there's a the standard notation for strings in Python is to include them or to enclose them within single quotes or double quotes. So in such situation, we can use this backslash notation for escape characters. So here the table is for reference only. So we just have to have the idea that when you wanted to include something like that, so for example here we have new line, something that we may be familiar, but what we need to understand is that whenever we need to include something that is unauthorized, an unauthorized character under normal circumstances, we have to use escape characters. And escape characters generally start with a backslash. So it is important when it comes to a representation of strings in Python and using some special characters within a string in Python. Here is a list of string operators. We have already seen most of these. The table is once again just for reference. So we have seen concatenation, we have seen repetition, slicing, range slicing, even membership, whether a certain character or a substring is included in a string and not in. So this is a set of operations allowed with strings in Python. So you can look for an exhaustive list. This list is for just for your reference, but a range of operations are available for strings in Python. So we have looked at some of the most important operations that can be performed on strings in Python. Okay, so we are moving on to another important aspect about strings in Python. So this is about formatting strings in Python. So generally, when you output strings, or when you display output, you would need to properly format the strings. Otherwise, it can look not very nice, especially if you are printing something. Especially if you are printing something on a paper, if you are trying to come up with, say, let's take an example of a printing of a bill, printing of a receipt for a shop, for example. So you have to be nicely formatting those numbers. For example, you'll be having rupee values, you'll be having quantity values. They have to be formatted accordingly. So in order to do that, string provides a range of formatting symbols or formatting methods available in Python. So here's samples. Here are some few examples of that. I will try to quickly go through some of these formatting symbols with the percentage sign. Percentage C is to for a character formatting, and percentage S is to string formatting, conversion of a string prior to formatting, and percentage I is signed decimal integer, percentage T is signed decimal integer once again, and percentage U is unsigned decimal integer, percentage O is octal integer. So octal numbers, a different number system, can also be represented in the Python output. And you can format them accordingly. So using this percentage O symbol. And another number system is hexadecimal. So percentage X gives you hexadecimal integer in lowercase letters, and percentage capital X gives you hexadecimal integers in uppercase letters. So these are some of the string formatting symbols available. There are many others as well. You can look further for exhaustive list, but we will also look at an example of applying some of these formatting symbols to format the output of a program. Here's the sample program, so where we need to print a certain statement. So look at this statement, I am. You can see that this special formatting character combination is available, percentage S. If you recall, that would be representing a string, and I am percentage D. So this is referring to a decimal value, years old. So if you did this, you need to specify what input will be, or what will be the values corresponding to these formatting symbols. For percentage S, it has to be a string, and percentage D, it has to be a decimal value. So you can actually map Kuma, this is a string, to this one, and 20, number 20, to this one. So when you execute that, when you run that line, the program will output I am Kumar and I am 20 years old. So that's how the formatting, they work as a placeholder. So you can define them in this output string and later replace those values using the actual values. So that's one example way of doing it, and we have some variations here in this for the same example. So all the 4 occasions here, the string is not changing. String is always a string, but we are changing the number, the representation of the number here. So previously at the first time we had decimal value, so now we are passing 15. So the first output would be I am Kumar and I am 15 years. Alright, so the second part, or the second example, you see that we have made difference. We have changed this formatting to octal number system. Percentage O means refer to the, or represent this number in the octal format. So even though we pass 15, the output would be 17 years. It is not exactly 17, because we are asking Python to display that in octal number system. So this is 17. If you convert that into decimal number system, you will get 15. So this is the 15 equivalent of octal. It is 17. So we don't read that as 17, because 17 means in the decimal number system, but this is rather 17 in octal number system. And then next we have floating point representation. So 6.2, so this has a special meaning, F meaning the floating point representation, and 0.2 meaning the number of decimal places, and number 6 here meaning the full or the total amount of characters to use to represent the number. So how much is that? How many characters is that? So here we have 1, 2, that's for the decimal places, and for the decimal symbol there's one more, 1, 2, 3, 4, 5. Already we are occupying 5 characters, but there's an additional character included as well. So here, because we do not have 6 characters, Python is including a white space character, because we are specifically asking for the number we need to have 6 characters, or a 6 character representation. Out of those 6, 2 will be for decimal places, 1 will be for the dot or the decimal symbol, and the rest will be for the number. So here in this notation, it will be printed as 15.00 years. And then the last part is, or the last example is having percentage x, that means hexadecimal representation. So 15 in hexadecimal number system would be F. If you had capital X here, this would have been a capital F. So these are some of the ways that string formatting can be used. However, I strongly recommend you to try these examples on your own and do different things, change these formattings and look at the output. So in that way you will have a much better understanding. So here's another exercise for you. Write a program to display the following symbol pattern. So there are six digits, 5 fives, 4 fours, 3 threes, 2 twos and 1 1. So think about it. So take some time, pause this video here and attempt this problem. So there may be multiple ways to do this. Even there could be a nested loop implementation that you can look into, but there are other alternatives possible as well. So please think about it. Try to write the program before you refer to the answer of this exercise. So here we are listing out one of the possible answers. So this is not actually using nested loops, though this is done using just one for loop and using the string repetition procedure. Okay, so you can see the multiplication operation here and the string is repeated accordingly. So I'm not exactly going to describe what is happening here. I leave that for you. So please try out this example and try to see what is happening at each step. I can recommend you to use Python tutor to look at step by step changes in the program. Brings us to the end of lecture 5. So here's a brief summary of what we have looked at. So we first looked at lists as a sequence in Python. We talked about many operations possible for lists in Python and how to use lists in different scenarios. And then we looked at functions and operators on lists, and then moved on to look at number types, and finally some details about strings and the possible operations on strings. That concludes lecture number 5. Thank you.